City's lecture. I'm going to start with our land acknowledgement prior to getting started. We acknowledge in Milwaukee that we are on traditional Potawatomi, Ho-Chunk, and Menominee homeland along the southwest shores of Michigamme, North America's largest system of freshwater lakes, where the Milwaukee, Menominee, and Kinnickinnick rivers meet, and the people of Wisconsin's sovereign Anishinaabe, Ho-Chunk, Menominee, Oneida, and Mohican nations remain present. So we feel it's important that planners who are working to create more equitable communities also understand there are a lot of different resources out there. So today, Jenny's going to be putting a couple links in the chat for you if you're looking for additional information on how to connect or additional knowledge on Indigenous communities. We also encourage you to take a look at the map. It's kind of fun to find out where you live or work, what the languages or tribal communities were initially there. So again, welcome online. Today, glad to be joined. We have Dr. Tracy Boyer here from UW-M's Freshwater Sciences. And so she's going to talk today about water conservation policies for cities. As you know, put your questions or comments in chat and we'll interject as appropriate, or we'll follow up at the end of her presentation with any questions that you may have. Just a reminder, we'll have a survey at the end to give us ideas for additional speakers and your comments on Dr. Boyer's presentation. And our next Innovative Cities lecture will be March 8th with Michael Mahaffey. He'll be talking about the innovation of public spaces, next generation cities. And then put on your calendar, we'll be coming out in the emails for April 22nd. That is our annual closure lecture. It's a Friday afternoon at 3:30. We're really excited to bring in Andre Brumfield from Gensler's office, and he's going to be talking about the 20-minute city through the lens of equity. So welcome today and welcome, Dr. Boyer.
Thank you. I appreciate it. If you cannot hear me, please say so in the chat and we will endeavor to make that more accessible for you. So today, I'm an economist. I was formerly at Oklahoma State University for 15 years. I'm a graduate of the University of Minnesota in applied economics. And today, the point of my talk is to talk to you about how water conservation can be approached as an economist and what tools municipal water managers can use in order to invoke water conservation. And you might say, why would this matter here in Milwaukee? We're on a gigantic lake, but there are conflicts about water in Wisconsin, and some of these tools might be necessary. So there's several reasons why water conservation, where water is not scarce, would matter. So first of all, you have to have the infrastructure to treat that water. So all of the water that is treated also goes out through the sewer system. So one of the constraints in Milwaukee is that our sewer system frequently becomes overloaded in heavy rain events. So you may have seen the Water Dropped initiative to reduce your water consumption during those events. So we're not as concerned about the price of water, but we're concerned about the inflows. And so water in Milwaukee is about $2.14 per cubic foot, which is about 748 gallons. So it's relatively cheap. And we also might care in terms of an equity issue, because water bills that are high or overuse of water, particularly for renters who may not have control over their infrastructure in their apartment because of leaks or old plumbing that overuses water, such as a old outdated toilet that uses high flow. So there are other reasons to induce conservation, even here in Milwaukee. And finally, the Waukesha diversion, which is approved under the Great Lakes Compact because it was needed to provide an alternative supply for the radium in the water. Waukesha has, under that contract, there was a desire to take less water out of Lake Michigan in order to conserve that water. So Waukesha could use some of these tools to reduce their water use in households. Next. Oh, I'll tell you next. Okay, so we're back on another. Okay, next. Okay, so water is not always priced. The price that you pay at the tap is a price to deliver the water and to clean the water to drinking water standards. water becomes priced in scarce environments. So scarcity is often the mechanism that induces people to price a resource. So we never know the worth of water until the well is dry. And water often flows uphill towards money, which essentially hints at the idea of political power. Next. So in Wisconsin, most of the water withdrawals are used for power generation. Only 8% is for municipal supply. So, and a small portion, 3%, is used for agricultural irrigation. The biggest agricultural draw is actually cranberry production. Next. If you look at the relative use of water in Wisconsin versus other states, Wisconsin is there in the middle. You can see that Wisconsin isn't the biggest user, and public supply is a small proportion. Whereas if you look at a place like California, that's okay, the public supply is a large amount in purple, and that's about the fourth bar chart from the left. So there are conflicts between municipal and agricultural water in most arid environments because they also happen to be places that are producing crops through irrigation. Next. So these urban-rural trade-offs are often evident, and this is an example from Oklahoma. And today I'm going to be giving 3 different studies of my research in Oklahoma for Oklahoma City as an example of these price mechanisms, non-price and price mechanisms, and talking about how effective they are. So Oklahoma City has a reservoir, Lake, the Hefner is shown above. It's used for recreation, but it's also used for the supply. That is transferred from the Canadian River and also Canton Lake upstream, another reservoir. Lake Canton was drained for the supply of Oklahoma City, and it took another 3 years to fill again for recreation. That agricultural and rural communities suffered a great loss from loss of recreation from camping and people who come to spend money when they're fishing and camping. So there is an opportunity cost to water, even if that water is not priced, and the rights are, how they are allocated also indicates an opportunity cost. Next. So the purpose of this talk is to talk about some of the tools that can help induce water conservation. Remember, in Wisconsin, we're a water-rich environment, but you might want to encourage conservation through these price and non-price tools so that people use less, so you don't have to build more infrastructure, you don't have to take more water out of Lake Michigan, and you don't have to treat it out the end of the sewer pipe. So we divide these into 2 categories, non-price and price mechanisms. So non-price mechanisms are mechanisms that are created to change your behavior through, say, education. If you're in the middle of a drought, studies show that education is very effective if you keep hammering home the do it for the public good call for save water. But as soon as the drought is over, people forget this and they go back to their ways. So other non-price, you could have a smart meter that informs people how much water they're using compared to their neighbors. So if they're using too much, it shames them into using less. And that's effective. Also very unpopular. Some cities in Texas have tried to put smart meters on electricity generation, and people have sued because it does give the generator information about the individual that could be seen as private. When you come home, when you leave, who's there, how many people are there. Home audits, you can audit one of your worst bills and go and help them to change their ways. That's an approach that the city of Tulsa has taken. You can have mandatory adoption of technology, and you can have mandatory rules. So many planners talk about municipal regulations. We're going to reduce the amount of grass that people are allowed to have because then they'll use less water. So those regulations are a non-price mechanism, and they have drawbacks if your city has small lots and people want large lots. They have different implications for desirability of neighborhoods. Certification is another interesting role to go. Advance, it has 3 animations. So 3 certifications I'm going to give you the example of. 1, WaterSense. So there are WaterSense certified toilets, shower fixtures, dishwashers, and washing machines. And that is an EPA criteria. And these standards help people to understand whether this good saves water versus another. You may be more familiar with Energy Star products or USDA organic labels, so that people can't make baseless claims. Other certifications that you may see in Milwaukee is the Water Drop Alert. This is not a certification, but it's an education tool. The MMSD will send you a text if you sign up for Water Drop to tell you when they're expecting a heavy rain event and they're expecting that the sewer might overflow. So why do we care? We care because the sewer district gets fined when these overflows occur, if they're over a certain number per year, and they contribute to algal blooms in Lake Michigan that close beaches and degrade the water quality. Another type of certification is a new one by the Water Council that they're developing for businesses, Wave Water Stewardship Verified, so that a business could be certified, and in many ways like a LEED certification. So price mechanisms are often more enduring in terms of inducing innovation. Mandating a technology like saying everyone must have a low flow toilet is a mandate that makes sense. Because if you incentivize someone to put in a new toilet, the toilet does not move with the homeowner when they move to another place. But if you buy them a new clothes washer, that might move with them. So you have to think about what are the worst culprits. A toilet built in the 80s uses 3 to 4 gallons per flush. A toilet prior to that might use 5 to 7. And in 1994, new regulations were adopted in the US where it had to be 1.6 gallons or less. A regular super low flow one is probably 1.28 gallons. These requirements were temporarily suspended under the Trump administration. Now they have been put back in place by the Biden administration. Price mechanisms are what I'm going to talk about, one example today. Changing the water structure so that water is more expensive induces people to conserve. Rebates for drought-tolerant landscapes are a way to codify and to permanently enable people to meet those demands. So if you put in drought-tolerant landscaping instead of a lawn, then you can use less water and people aren't likely to flip that immediately. A rebate for a low-flow toilet is also a price mechanism. You're reducing the relative price. However, many of those rebates have been inaccessible to the poorest households and renters because older homes have a lot more wonky things in them and they require professional installation in many instances, which is a large barrier to adopting those mechanisms. So while all of these things are great in theory, some of them are not equal in access. Next. So I won't spend a lot of time on this, but if you look at these rate structures, let me give you one example of a uniform rate structure. Says that I pay $2.14 in Milwaukee per gallon per 100 gallons, and I pay that for every unit. So you know you're paying that price for every unit, but it doesn't change your behavior for the higher unit. The third structure, the inverted block rate structure, also called an inclining block rate structure, can be set at a low level, say $2 for the first 5,000 gallons per month, which is about what an average household that isn't conserving much would use. So if I put it at $2 for the first 5,000, which is the first step, and then I up it to say $4 for 5,000 to 10,000, that induces conservation at those highest, most useful uses. The example I'm going to use in Oklahoma City is that in the summer, people water their lawns 2 to 3 times a week, and that is the most highly treated water in the world to a drinking water standard, and it's being dumped on lawns, sometimes at the most wasteful, highest evaporation rate time. So they also could induce a seasonal rate structure where it's higher in the summer, which is something that Oklahoma City toyed with but never adopted, because one of the biggest reasons for them to adopt a conservation structure was to avoid diverting from other sources, which was controversial, and also because in the summer the water pressure was too low to make it to some of the outlying areas because the grass was being watered in the summer. So next. This graph shows that decreasing block rates on the third row have, that's the opposite, where you use more, it gets cheaper, have become less popular over time. Increasing block rates have become more popular, and uniform volume charges have become less popular over time, from the 80s, going from 35% to 30 in 2012 to 2013. Ironically, some of the places, until recently, even had a flat rate, which was true in Sacramento. You have a meter, you pay a certain amount a month, regardless of what you pay. So you can see inherently that rate structures are very important. Now, they're also controversial because we charge for the delivery of the water as a municipality. Municipalities also make money. In the small town where I lived in Stillwater, Oklahoma, excess money made from water is then put into the rest of the general fund. When you adopt conservation, you have to make sure that you don't induce so much conservation that you do not have enough money to cover the cost to deliver the water. And because water is a natural monopoly, it means that once you have the infrastructure in and you're the game in town, you have declining costs to serve people, so it's harder for anyone to enter. They're not going to use this, they're not going to be able to use the infrastructure. So water is highly regulated, and changing the rates often goes through a rate board depending on which state you're going through. And then the third complication is that we don't even charge the true cost of the water, because we charge the average cost to deliver that water, not the marginal cost to deliver that next unit. Next. Okay, so I'm going to give you 3 studies that I did in Oklahoma, and I'm going to race through these. Oklahoma is a semi-arid state, and as you can see, the green parts are the areas where they were above average precipitation, and the brown parts are below average precipitation. At the time that we did this study, they were in a deeper and more prolonged drought than the Dust Bowl. But the conservation measures that were put in place by the Farm Service, USDA, kept it from being another Dust Bowl. However, municipal water was in short supply, and some adjacent communities, such as Lone Chimney, ran out of water and had to tank in water. So the historic 4 years of drought from 2010 to 2014 had rain patterns less than the Dust Bowl, and they took detrimental tolls on surface water. Next. So we had a research partnership with Oklahoma City Water Utilities as part of Oklahoma State Agricultural Economics and Landscape Horticultural Studies, architecture, from 2013 to 2017. We were contracted to create a water conservation site and municipal sites to demonstrate drought-tolerant landscapes throughout the state. And I was tasked with looking at the data about what would induce conservation. It was a unique opportunity because normally municipalities do not hand over their individual ratepayer information to academics. They usually use consultants that then give them an elasticity of demand, and they use that to design their rate structure based on their cost to deliver that water. So it was a unique opportunity. So Oklahoma, even though it has increasing water demand, has been able to decouple the population growth with the demand. So they're able to meet the demand for water because of conservation. However, residents use anywhere from 35 to 70% of their water on their landscape in the summer. So residential landscaping has a huge potential to conserve water when it is most demanded in these communities. Next. So our research objectives were to determine if household water conservation techniques, what had been adopted indoors and outdoors, to estimate the elasticity demand to price, which means how responsive are people to changes in price? Do they lower their consumption? And the third was to collaborate with Extension to inform Extension, to inform what policies would work. Next. This is a map of Oklahoma City in the middle and the adjacent counties that were serviced by the provider. Next. A telephone survey was conducted from 2013 to 2014 with 784 households. These 800 households were randomly picked out of 120,000. We used GIS to pair the consumption with the assessor's data on house characteristics. Next. So we assumed that household characteristics were a proxy for what kind of household this was. We had household characteristics from the survey, and we had house characteristics from the assessor. So we had the number of residents, their education, gender, race, ethnicity, and income. And then we had house characteristics such as the yard size, the house size. So we assume that these affect the adoption of water, and those attitudinal variables also come into play. Next. So we did logit models, which the dependent variable was 0, 1, for 1 if they adopted the method and 0 otherwise. So it was any indoor adoption method, such as low flow, water sense, labeled faucets, shower heads, toilets, water conserving or Energy Star certified dishwashers, or as a function of all those household and attitudinal variables. And then a second model was for outdoor, looking at irrigation audits, drought tolerant lawn or garden, or rain barrels. So the independent variables were demographics and that parcel information. It's unique in the sense that we use the assessors data, which is more likely to be accurate than the homeowner's recollection of the size of their acreage and their dwelling. Next.
There's a quick question as you're talking about this case study. There's a question about water irrigation on farms, and then just generally how do residents get their water? Is it groundwater? Is it surface?
In Oklahoma City, it's surface water from a reservoir. It comes from the Canadian River, but the upstream reservoir is contracted for rights, and that was Canton Reservoir. This study was conducted because they had also contracted with the Army Corps of Engineers to build a separate reservoir that they now had to pay for and build a pipeline to in order to further guarantee supply. So the second study I'll talk about, the elasticity of demand, was done to determine the rate to pay for the other reservoir. So in Oklahoma, there are 5 ecoregions, and the Panhandle gets 7 to 8 inches a year in 2 days of rain, and the Southeast gets 44 inches a year. So it really is a great mesocosm of the arid West and the semi-arid Midwest. And so the cropping activities vary by irrigated wheat and non-irrigated wheat. And for agriculture, the Panhandle uses the Ogallala Aquifer For the southern part, they use the Simpson Arbuckle Aquifer, which was a lawsuit between the state and the local community. And in other areas, they are rain fed. So there are conflicts between agriculture. There are no natural lakes in Oklahoma. There are 144 major reservoirs, mostly built by the Army Corps of Engineers for flooding, irrigation, and hydropower. They're more important for recreation, and we've done that study if that's ever of interest.
Thank you.
Okay, so I'm not talking about irrigation here. I'm mostly talking about Oklahoma City, and their main supply is surface water. Other places do use groundwater. Norman, University of Oklahoma, uses groundwater, and it was tainted with arsenic, and they were forced to put in very expensive arsenic treatment systems. Okay, so here are our models here. I won't spend too much time belaboring the regression statistics, but the significant variables are education, and as you can see, they are more likely to adopt indoor and outdoor conservation with higher degrees. And you can see that indoor adoption, I need to go back to my notes, sorry. It's been a long time since I've used this. The only thing that was, is there another slide? Next one. Significant? In the next slide, go to the next slide. In the outdoor model was Bermuda, which is the second column toward the bottom. So when a homeowner adopted Bermuda grass, they were having Bermuda was the only outdoor adoption that was significant. And so what that says is a homeowner is very invested when they rip up their entire lawn and put it in that conserving grass type. Now the indoor estimates on Model 1 and Model 2, we found that having adopted house age was slightly more likely to indicate adoption of conserving features and to have said that they had done it in the last 5 years, because as houses age and people move into an older house, they're putting in things like new toilets and new shower heads. Next. Next, we don't have to belabor those because we don't have much time. So education and upper income explain indoor and outdoor adoption. They are statistically significant. Those households making less than 40K are less likely to adopt compared to those making over 75,000. And households with Bermuda grass in their lawn were more likely to adopt water conserving behavior. So we didn't find any magic bullet that would tell Oklahoma City how to induce conservation based on past behavior. And that's one of the drawbacks of a cross-sectional study of behavior that's already occurred. It's hard to predict what people will do in the future under something that has never been done before. So if you want to create a program where you're paying people to put in low flow toilets, you would have to do a survey that looks at their hypothetical willingness to adopt this. Or you would have to look at another community that was similar, like say in Texas, to see how well it was adopted and who adopted it. So next. Accessors characteristics were not significant, so we didn't find house age, market value, and house size except for that one indoor model on house age, and it was 1, so it wasn't going to change it in a big parameter. Race, gender, and ethnicity were not significant except for African American households, which were less likely to adopt outdoor conservation, I believe. Older residents were more likely to adopt outdoor but not indoor conservation. Next. Attitudes for water consumption, if they believed the drought was going to be prolonged, they did matter for indoor. And households that adopted indoor were more likely to adopt outdoor conservation. So household perception that the drought would continue did increase indoor adoption. Next. So the conclusions for the policymaker are that education and access to information about consumption would be helpful to residents to reduce demand for water, but we didn't find any huge smoking gun apart from education and income. Next. The second study we did was an elasticity of water demand study. This was my graduate student's PhD thesis. And we had the monthly consumption for 10,000 randomly selected residential households. Remember, we had 120,000 households. So we randomly selected 100,000. We mapped them again using GIS. We used weather data, rainfall, and maximum temperature for each of their locations and the time of consumption. We used household characteristics such as the house value as a proxy for income, because in this study, we did not have individual survey data. So this is data that was available from the municipality, and that data was then projected upon to the lot from the assessor income. So we had parcel size and the year constructed. Next. So past studies have estimated water demand. Many of them were based on flat rate pricing on increasing or decreasing block rate structure. In Oklahoma City, we had a volumetric study. So you paid the same amount for every unit. Most of those demand studies do not use household characteristics or climate data. Oklahoma City has a mesonet system for weather where you're never more than 5 miles away from a weather station. And it is collecting data on a 5-minute interval throughout the entire state for the last over 20 years. So it's unique in that we could pinpoint this. Very few studies exist on volumetric pricing. Next. So the objective was to estimate water demand while also estimating the factors that affect water demand, such as house age. So remember, in 1994, all toilets had to meet that lower water consumption requirement. Next. Oops, back. We wanted to identify the variation in price and income elasticity in before versus during drought, and the summer high consumption period versus winter, the low consumption period. Next. So the problem is that water pricing has a simultaneity problem. Average prices are determined by the consumed water quantity. We used average prices. We rearranged the price variable. And regular ordinary least squares, which is what SPSS will spit out for you, that's about as sophisticated as SPSS is, leads to biased results. So a two-stage least squares method was used. The first stage, the endogenous price variable, is regressed on a set of variables that are not correlated with the error term, but highly correlated with the endogenous variable, which is price. And the second stage predicted that average price in the first stage. Next. There's someone in the waiting room. Okay, so what did we find? We found that during the high consumption period, I didn't do my average cheating by marking them with what was significant. We found that we found one that price was significant. And temperature was significant. I apologize. We did this study a very long time ago. I should have gone back over the variables. Go to the next slide. Year built was significant. So The newer the house was, the less water that it was using. And this was significant. We didn't find that there was a lot else that was significant, but is that a problem? Not necessarily. So many fields say, even in business, for estimating a demand for a problem, will take data out if it's not significant. And that's called data mining. In economics, that's a no-no, because data mining, if something should be in there by theory, it should be in there. If you take it out, it becomes an omitted variable and it's biased. If the sign on the coefficient is in the wrong direction, then you know you have something that you seriously need to worry about. So the dependent variable in this model is water consumption. And as you can see, the year built decreases water consumption. Parcel size increases water consumption, but it's not significantly different between all building periods, pre-drought and drought. And the average price of the home, pre-drought and during the drought, you can see that there is less of effect during drought than there is pre-drought, which is normal period. And you can see that temperature increases consumption as we expect it to. And that rainfall decreases consumption as we also expect it to. And income increases consumption as we expect it to. Next. So water demand was unresponsive to price. That means it was inelastic. So for every penny you increase it, it did not decrease by more than a penny. That's what it means. So it was inelastic to price. Block rate pricing imposes a marginal cost on water consumption, which does induce residential water conservation. And the beauty of this study was that the city took this data. We got the data as in discussion with them. It was not the original intent of the grant. The student used the data for her PhD, showed the inelasticity or the unresponsiveness of consumption to price, which is bad if you're trying to induce conservation. So they use this data with a consultant to figure out their cost to deliver it. And they ended up in the subsequent study that we did, having a 10% increase in price, which induced a 14% decrease in water use, which made consumption elastic. So that began in 2014. That is an inclining block rate. And that second tier was applied at a very conservative rate. 10,000 gallons was the average use during the worst drought since the Dust Bowl. And therefore, that's not the cost to survive. 5,000 would have been about what would have made sense. So even setting the first increasing tier after 10,000 gallons per month induced a change in people's behavior. Next. Did it work? So the next study, after the 2014, we used that data and estimated that a 10% increase in average price decreased volume 14%. The non-price factors that affected it, increasing parcel size increased demand 1%, a 10% increased demand 1%. That's the watering the lawn. The residence value increased, a 10% increase in the value. Demand increased 1%, decreased 6.5 for a house built post 1994 compared to houses built prior to 1994. That's the toilet factor. Decreased 1% for every inch increase in monthly rainfall. So the more it rains, the less people use. And it increased 1% for every 1 degree Fahrenheit increase in monthly max temperature. So the hotter it was, the more they were watering. Next. So comparison For uniform pricing, the elasticity was 0.38. And for the increasing block rate pricing, the elasticity was 1.38. So how do you interpret that? On the left, on the top left, a 1% increase in pricing decreases the consumption by 0.38. So you're not getting more than what you're increasing. An increase in block rate pricing, a 1% increase in price decreases consumption at 1.38 at 138%. So no, 1.38. So you get slightly more because of a 1% increase. So block rate pricing works. It works in the literature. It worked here. Next. Time check, 15 minutes. Got enough time. So for a household consumption with a parcel size of 0.22 acres, which would be generous in a place like Shorewood or Whitefish Bay, with a 2,200 square foot house with a value of $108,000, lagged average price of $13 per 100 gallons. That's the combined of the base fee and the higher tier. Built before 94, would have predicted 33,000 gallons with uniform pricing. The block rate pricing would have predicted 25,000 gallons. So you can see that you're inducing a 8,000 gallon savings. Next. So the proportion of household water consumption from February 2016 to July 2016 of all single family residences. So most of them in February 2016 were under 10,000 gallons, but you can see the effect in July on the right-hand side, only 68% were under that. So what the block rate pricing is getting at is that wasteful yard and car washing habit or swimming pools. So those both are a factor. And you see that many of those, very few of those households use more than 10,000 gallons. But the city was able to conserve a massive quantity of water with that change in pricing structure. Now, is that fair? That's the question. So it only affected, it didn't affect 32% of the households in the summer. So it got at basic needs under 10,000. So the price didn't increase under 10,000. So you can use that structure to make sure it's equitable, because watering your lawn in the summer when it's Bermuda is not a basic need, because Bermuda can die and go dormant. Well, it doesn't die, it goes dormant all summer. It turns brown and it comes right back in the fall when it starts raining again. Next. So it was effective. A 10% increase induced 14% decrease. Demand is responsive in the second study. And you could, pros of the two tiers. It's easy to understand, it promotes consumption, conservation, and it does not allow an increase. It allows an increased articulation between that winter normal and that summer increased demand for luxury uses. Next. So finally, I'm going to talk about extension. Does it work? So extension is the word for outreach at land-grant institutions. Every land-grant institution has 3 missions: research, teaching, and extension. Madison is the land-grant institution in Wisconsin. In Oklahoma, Oklahoma State is the land-grant institution. So we set out to ask whether commercial businesses, because the city was appalled at the number of commercial businesses that were watering their lawns in the winter and putting ice on the lawns. The grass doesn't grow in the winter. It doesn't need to be watered. In the summer, they were watering the sidewalks. what could they do for this problem that looked blatantly bad? So we agreed to do a commercial survey of businesses. I really don't suggest this as a research vein. If you are a municipal planner, businesses are not interested on the whole in returning these forms. It is very hard to find the person who is in charge of returning the form, makes the decision, and having them return it. So that is a pro tip. Okay, so we surveyed 381 commercial businesses that we got from the database of people in the customer database for Oklahoma City. And we wanted to look whether they would adopt soil moisture sensors, smart irrigation, or a landscape irrigation audit if the city were to approach them. Next. So we use something called contingent valuation. Remember, I told you when we take data about adoption, it's what's already happening. We can't talk about what's hypothetical. A stated preference survey like contingent valuation allows you to ask a hypothetical. So would you be willing to adopt this to have X amount of savings in your landscape is how we promoted this. So we wanted to estimate their willingness to pay for reclaimed water to hedge against future shortages. Oh, sorry, that was the prior study. I'm on a 4th study. So the prior municipal one, we found that the takeaways were commercial businesses will not answer your survey. They do not want to adopt smart irrigation. They might accept an audit, but the decision that is made is to hire a landscaping firm and you set it and forget it. So the extension learning tool out of that is to reach the landscapers, not to reach the business itself. And then the landscapers to communicate that they needed to come up and retool that whole system so it's not spraying in the winter, it's not spraying on the sidewalk. Okay, so is extension effective? So we did an internet survey of 486 Oklahomans to see if they would be willing to pay for, how did Oklahoma City put it? It was reclaimed water from the sewage system that would go back into the water supply via a river. So it wasn't even directly into the water supply. And what we found was that respondents who had higher incomes, were male, and rented their homes were more likely to accept the reclaimed water bid. People who own their homes were less likely to accept the reclaimed water at all. Even if it lowered their future risk of having shortages and low pressure, women are more likely to dislike anything that smacks of unhealthy because it was reclaimed sewage water. Owners, we suspect, did not want this because they felt that if they were in an area that was receiving this water, their home values would go lower. So they were on average willing to pay $3.47 and $420 per gallon to preserve, that is males and renters per 1,000 gallons to preserve the water supply between the with and without attitudinal variables. So the takeaway is really consider very carefully in the prior study about talking to commercial homeowners. And 2, in this study, we tested describing 2 different variables, 2 different ways as well. So we had an experiment between attitudinal variables and non-attitudinal variables. Did they think drought was more likely? If drought was more likely, they were willing to pay more. But we also had a subset that I'm not reporting on here where we explained how dirty the water was and they were swimming in it versus how much cleaner the water was that was being returned to the water that would have been the source. And as soon as we started discussing E. coli, they weren't willing to pay for the water. So science communication is a thing, and we failed at it. As soon as you discuss E. coli, people freak out. Next. Here's a set of references of these different studies and some of the more accessible fact sheets that we made based on this research for out of extension. Next. Finally, I'm the undergraduate coordinator for the Freshwater Sciences undergrad program. It started this fall. It's going gangbusters. I just wanted to plug this. If you're out there and you have a college senior who's interested in coming to UWM, we also have an established professional master's program for people who are coming back to do a second degree, a master's thesis program, and a PhD. But the undergrad is exciting. We're also developing in the next few months a 5-year plan so that you can get your undergrad degree and your master's in 5 years. It's a very rigorous degree, but it is hands-on, and it involves a lot of the work on our research vessel, the NESCAP. And it includes economics, in the case where I and Dr. Price are both water economists, and it includes a little political science, a little computer programming, and a lot of chemistry and biology and ecology. Thank you.
Thank you. So how do you think this sort of applies to Wisconsin? I mean, are the takeaways of, obviously the newer house would be more efficient based on code, but is there any sort of thought on changing habit?
So habits, so the second practice, so in households, the toilets are the easy to get at. They're using a lot of consumption. Showering is the next one. Most people do not like the low flow shower heads. It's like being in a mist. And it's something that renters, for instance, take out of their showers regularly. So the answer is, how does this apply to Wisconsin? Well, it certainly applies to Wisconsin where there are concerns about groundwater withdrawals. So if the groundwater is the supply and it's a non-recharging aquifer, then conservation is of the essence. It also applies to places like Waukesha. They had to get special permission to draw water out of Lake Michigan, which is very costly to move that water from Lake Michigan to Waukesha. So, and the third instance where it applies is the issue of this, the heavy rain events in Wisconsin. The water drop program through MMSD is asking you to use less water during those events. So if you want to conserve water during these events and you absolutely must run your dishwasher, if it's a Energy Star, it's using less water. They're often not marked for water conservation. If you're using a WaterSense front loader, it's using less water if you have to use that machine. They're asking you not to, but you can use the same intuition here. MMSD is currently giving people rain barrels and constructing water gardens. Another tactic in their suite of tools could be to install toilets. But per volume in an event, capturing all the water or they're also disconnecting the roof drains that go straight into the sewer. But per event, a toilet isn't going to be your biggest use, but it could be part of a suite of options that MMSD could do to lessen that flow. But a real comparison of how impactful each of these practices is per cost of MMSD to implement them is really needed.
Mm-hmm. I think what's interesting also from a planning and sort of urban design city perspective is there's a lot of green infrastructure strategies out there, and obviously MMSD has really a variety of programs and grants. But there's always that challenge of, am I required to do this or should I do this? And what's the benefit to me as a property owner,
Mm-hmm.
especially when you're talking about businesses versus
Yes.
homeowner. I don't know if you're doing any research on, installations, because I think that one of the discussions is how is it working, right? The benefits of my neighbor, or almost like peer pressure, right? Like,
Mm-hmm.
oh, I'm seeing others do this and it's actually having a positive impact, maybe on my financial bottom line, but more so on the environmental bottom line. I mean, do you, in
So-
terms of economics, do you look at those sides or any research?
Yes, you can. So you can take some of these, and an avoided cost is a benefit compared to the cost of implementing that plan. So my former PhD classmate, Laura McCann at Missouri, has done a lot of research on green infrastructure and what willingness to adopt it is. She's at University of Missouri, Columbia. So her work is accessible. Matt Winden did a study for Milwaukee on green infrastructure. He's at Whitewater, but I don't believe that work ever got published. But so the takeaway is that all of those price and non-price mechanisms apply to green infrastructure. So the problem is that my water bill affects me. My externality, the negative effect of something flowing off my property, does not affect me. So I have less incentive to internalize that cost by building a rain garden. However, we know that price mechanisms work and they're enduring. But the question is it enough to do it through price to target people versus a municipality mandating it when it goes in? So there's a rain garden there's a green roof that was established on the School of Freshwater Sciences, but it was let lapse because we don't have the ongoing funding and manpower to take care of it. So installing it versus maintaining it becomes separate costs. But many of the tools that I discussed here could apply, and there is absolutely a neighbor effect. That rain garden's ugly. I just want to get it off my property. I want to put a pipe and send it down to the sewer. I don't want that rain garden to swamp my yard. Extension is all about that. So showing someone that a rain garden is beautiful, it's not hard to maintain, would be part of that education. And in all of the adoption studies for agriculture, having a neighbor adopt it is like a conservation tillage, will induce the other neighbors to adopt it. There has to be a first mover. So the answer is yes, you can use some of these tools and you might use them together. I'm going to use education. And then once I have some education, I'm going to start an incentive program where I give somebody a tax rebate to put it on their roof. And I'm going to use this one to show how it's done. So
That's been my experience of, first question is, how much is it going to cost to maintain, right? So I think seeing that other benefit is helpful. Are there any questions online?
No, I have a question. Have you seen states that have had a lot of bipartisan effort behind any bills that use price mechanisms? Have there been any great success stories of that being implemented at the state level?
well, California was in the deepest drought of its history a couple of years ago. And they had a state level requirement that municipalities meet their conserve water at certain levels. And each municipality used a different mechanism. And it ended up being implemented in very unfair ways. There were Southern California municipalities that created inclining block rates that were giving people $2,000 water bills. Other cities mandated watering bans and car washing bans. And one of the biggest things that you don't even realize is when you go to Florida, no one ever gives you water at your table. You have to request it. Residents are mandated not to give you water at your table. And it's not the water at your table that's the problem, it's the dishwashing that's using all the water. So in some instances, a nudge, a reverse nudge, like you have to ask for the water, is very effective in mandating it works. In other instances, it backfires. So let me give you a mandate that backfires. Oklahoma City, when we went to talk to them in 2015, first out, I said, you need to raise your prices. They said, we will never do that. They did. They decided to go to every other day watering. So odd and even. What happens is everybody freaks out. They say, oh my gosh, I can't water on my other day. And they overwater on the days they water. So sometimes mandates make sense when the cost to enforce the mandate is prohibitively expensive. I mean, the cost to create a tax or a pricing mechanism. And sometimes they don't make sense because they create perverse behavior like the every other watering day. So there's that paper on household conservation has a really nice review of all the different price and non-price mechanisms if someone wants to read that.
So the bottom line is it's complicated, but
Yeah.
slowly people are changing their habits. So did you put this survey in? So for those of you online, Jenny will drop in the survey link. If you could please fill that out, give us some feedback on what you heard today, as well as future ideas for additional speakers. And just a reminder that our next Innovative Cities lecture will be March 8th. So again, look for an email, please register for that. And then mark your calendars for Friday, April 22nd for Andre Broomfield coming in as our Cosure lecture. So lots of different ideas ahead and hoping that everybody stays safe on the ice, if you're local, that is. And thank you again for joining us for today. Really appreciate your insight and understanding a little bit more about the program at School of Freshwater Sciences as well. So thanks.
Great, thank you.
All right. Have a good day.